video tutorial, we are going to begin exploring arithmetic sequences. Now, when we're looking at an arithmetic sequence, we are considering a list of numbers where each successive pair of terms have a common difference between them. One example of an arithmetic sequence would be the values 2, 6, 10, and 14. We can see that these four numbers form an arithmetic sequence by considering the common difference that occurs between these terms. We can see that each term value we increase a value of 4. And because this common difference is the same between all of these terms, we can say that this is an arithmetic sequence. So our 4 is representative of a common difference, which we use the variable d to represent. We can also name these terms outside of their actual numerical values. Whenever we're given a sequence like this, we can see that these 3 dots indicate that the sequence continues. But because there's no dots prior to the 2, we can say that this number 2 is term 1 or T1. And then each successive term increases in one term value. So 6 would be term 2, 10 would be term 3, and 14 would be term 4. We're going to use this understanding of what an arithmetic sequence is to help us utilize the concept of recursion. Now, when we look at recursion, we are using this to help us define the next term by using the value of the previous term. And we are going to use that using a value called Tn plus 1, where Tn is the term value that we know. So as an example, we could consider term 1 to be term n. And in order to get to term n plus 1, we are increasing the value of the term or the position of the term by 1. So in this case, our number 6, or our term 2, is going to be the same as term n plus 1. So in order for us to get to term n plus 1 using term n, all we need to do is start with term n and either increase or decrease it by the common difference in the sequence. Now, it doesn't matter if our common difference is positive or negative, we can still represent it using this addition sign, as if it is a negative number, we will end up going term n plus negative whatever the difference is, and it'll turn it into a subtraction for us. One thing we also need to consider when we are defining this sequence using recursion is we also want to indicate what value term 1 is. Sometimes you're going to see term 1 being defined just as T1. Sometimes you're going to see it defined using the variable a. So if we were to represent this sequence on the board here using recursion, we would say to calculate term n plus 1, we take term n and we're going to add on our common difference. I accidentally put the variable back in there. We're going to add on the common difference of 4, given that term 1 is 2. So that is giving us our instructions for the relationship between each term and what our first term is going to be. Now that we have established our recursion with our arithmetic sequences, we can use this to generate terms within a sequence. We're going to start off by having a look at this example here, where we have been asked to generate the first 4 terms of the arithmetic sequence given this information. So we've been told that for each successive term, we need to take the term before and add 10. with an original term of 7. So we can start by saying our term 1 is 7. In order to find our term 2, our recursion relation is telling us to take term 1 and to add 10 onto it. Now we've already had our term 1 defined for us, so we can say that to get term 2, we would do 7 plus 10, which is 17. This process can be repeated for terms 3 and terms 4, whereby we're taking the term before and adding another 10 onto it. And then finally term 4, we'll have term 3 plus 10, which will give us 37. So we're taking each successive term and adding that common difference onto it. So we can say, therefore, the first 4 terms are 7, 17, 27, and 37. And we could theoretically use that recurrence relation indefinitely to calculate as many terms as is required. Now, at times we are not going to be given the full recursion relation, such as this second example here that we're going to look at. Instead, in this instance, we have just been given an A value of 12 and a D value of -2. So we need to be able to take those two pieces of information, put them into our recurrence relation, and use that to generate our first 4 terms. Now we are going to use our standard form here of the recursion relation to help us. And we can say that to find term n plus 1, we can take term n and add onto it our common difference. In this question, we've been told the common difference is -2. So I'm going to place that in the formula like so. We've also been told that we have an A value of 12. We know that term 1 equals A, so that means our term 1 is 12. So we can now use that information to go ahead and calculate our first 4 terms. We already know that term 1 is 12, so we don't need to do any calculations there. To get to term 2, using the information in our recursion relation here, we can say that we can go T1 minus 2. 12 minus 2, which is 10. We can then repeat this process for terms 3 and terms 4. Whereby we take the term before, apply the common difference, and then we have our next term. So we can take those original A and D values that we were given, put that into our recurrence relation, and use it to generate the first 4 terms. So that's a quick little snapshot into how we can represent our arithmetic sequences using a recurrence relation. Let me know how you went in the comments below with your arithmetic sequences questions, or let me know if there's any other video topics that you would like to see covered. Happy solving!